Okay, we have this oxidation reduction, and it happens in basic solution, and it'll tell you that, but this is going to be basic. And what we have to do first is figure out the two half reactions, and to do that you need to know the charges. So there's certain elements that you can just trust for their charges. Column 1 will be +1, and column 2 will be +2. Hydrogen in covalent compounds with no metals will be +1. Column 13 will be +3, and fluorine will be -1, and oxygen pretty much always -2. I have yet to see a problem where it's not -2. The exception is peroxide, but I haven't seen a problem with peroxide yet. So we're going to trust those elements. So that means that this oxygen is -2, and you can tell that we'll have -2 times 4 is -8 here. It's an overall negative charge, so that means the manganese must be +7. Now, this S is -2. I forgot one, but if it's by itself, you can also trust that it has a 0 charge. So this S is 0. Then we have M, N, and S. And you might be wondering, how am I going to know which one is which? That's okay that you don't know what the charge of this is yet. What you do know is that this is 1/2 reaction. So the only other thing left to be, this is going to be the Leo. The only thing left to be the Gur is the manganese, because O won't change its oxidation state. So we'll write the Leo is that. Okay, the S's are already balanced, and we don't have any H's or O's to balance, so we're going to just balance the charge by putting 2 electrons on this side. And it makes sense that the lose electrons their lost electrons are on the product side. So we know that the manganese must be the Gur, even though we can't quite figure out its charge. And we know it's going to go to MnS. Now, do you see how we have an S here? That means that we need to have a source of S as a reactant, so we're going to reuse the S-2. Okay, so we're balancing everything not H's and O's first. So Mn is balanced, S is balanced. We will balance the O's next with water. There's 4 O's on the left, so we need 4 waters on the right. We're going to balance the H's next. There's 8 H's, so we get to put 8 H pluses. You balance the H's with H plus. The last thing to balance is the charge. We have +8, -1, and -2, so this would be a -3, and this is a +8. The overall charge on the left is +5. On the right, there's nothing here and nothing here, so the overall charge on the right is 0. That means the change in electrons must have been +5 electrons on the left to make it even on both sides. Okay, the half reactions are balanced. We're going to add them together, but we have 5 and 2, so we have to make that even, because whatever was lost from one has to be gained by the other. So we'll multiply this by 5 and this by 2. Okay, now we're going to add them together. So you can see that the electrons will cancel. You can also see that actually, because we have H plus over here and H2 over there, and those are the only sources of it, we can just from here just add. So we'll have 5s-2 plus 16 H pluses plus 2 MnO4 minuses plus 2s-2s makes 2 MnS's plus 8 H2O's plus 5 S's. Okay, we should check it. There's 5 S's. Oh, I forgot to add these two together. We're going to make this 7 S's. 7 S's on the left, and 5 plus 2, 7 S's on the right. 16 H's, 16 H's, 8 O's, and 8 O's, and 2 Mn's. The overall charge on the left is plus 2 minus 2, so 0 on the left and 0 on the right. The last part is for a basic solution. We need to get rid of the H+. So we'll add 16 OH minuses to both sides. That makes this H and OH. Do you see how they're going to make H2O with a neutral charge? This will become 16 waters. Those 16 will cancel with this 8, and we'll have 8 waters left on the left and 16 OHs. So the final will look like this. Okay, and then you're done. And it still works out because there's 8 H's on, 16 H's now on the left and 16 H's on the right.